Find the length of the missing side. The triangle is not drawn to scale. So this is going to be the review for the upcoming test that we're going to have for special Rigts triangle. And I'm doing number 1. We know that we're going to have to use the Pythagorean theorem, which is a squared plus b squared equals c squared. This will be 8 squared plus 6 squared equals c squared. So we have 64, which is 8 times 8, and 36, which is 6 times 6, equals c squared. So we have 100 equals c squared, and so the value of c, you have to get the square root of both sides. So c will be 10. So this distance right here is 10. Triangle ABC has side lengths of 3, 4, 5. Do the side lengths form a Pythagorean triple? So a Pythagorean triple behaves like the Pythagorean theorem. So we have 3 squared plus 4 squared equals 5 squared. That's what you're checking. So we have 9 plus 16, and you want to check if that is equal to 25, and sure it is. So 3, 4, 5 is a Pythagorean triple. Wayne used a diagram to compute the distance from Ferris to Dunlap to Butte. How much shorter is the distance from Ferris to Butte than the distance Wayne found? Okay, so we're going to have to find this distance here. So it's going to be 15 squared plus 20 squared equals c squared. So to use my calculator, I would just have to find the square root of 15 squared plus 20 squared. So I'm just going to type in here the square root of 15 squared plus 20 squared, and the distance here is 25. So going from Ferris to Butte, that's 25 miles. Going to Ferris to Dunlap to Butte, that's 35 miles. So how much shorter is it? It's shorter 10 miles. A triangle has a length of 27, 79, and 84. So here is 27, 79, and 84. We have to check if it's a right triangle. So we just have to use the Pythagorean theorem. 27 squared plus 79 squared. And let's see if it equals 84 squared. So I'm going to say 84 squared equals 27 squared plus 79 squared. It's false. So this is not a right triangle. So it's not a right triangle because it doesn't equal that. Now, if 84 squared is larger than 27 squared plus 79 squared, it's obtuse. So 84 squared is 7,056. 27 squared plus 79 squared. Okay, so it's obtuse. So this is an obtuse triangle. Number 5, a triangle has the side lengths of 24, 143, and 145. So here is my triangle. So this is 145. Of course, it's not drawn to scale. 143 and 24. And if it's a right triangle, it's going to follow. The Pythagorean theorem will be true. So you have 24 squared plus 143 squared should equal 145 squared. So let me go to the calculator. So we have 145 squared. Enter. So it's 21,025. 24 squared plus 143 squared. 21,025. So it's a right triangle. It is a right triangle. So this is what I said earlier. You're gonna make a triangle, and this is 37, 35, and 12. And we have to determine if it's acute, obtuse, or right. So we have 37 squared, and we have 12 squared plus 35 squared. So we have 37 squared, and we have 12 squared plus 35 squared. It's equal. So this tells us it's going to be a right triangle. Number 7, we have a triangle has a length of 23, 6, and 28 classify as acute, obtuse, or right. So let me go ahead and draw the triangle. So this is 28, this is 23, and this is 6. So we have to check, is 28 squared equal to 23 squared plus 6 squared? Is it greater than or less than? So let's go ahead and go to the calculator. So we have 28 squared, enter. We have 23 squared plus 6 squared. And it is 784 is larger than 23 squared plus 6 squared, so this is obtuse. This is an obtuse triangle. Find the length of the hypotenuse. Remember, in a 45, 45, 90, we know that this side measurement is the same as this side measurement, and it's going to follow this pattern. So we have x, x, and this is x squared of 2. So if this is 3 square root of 2, and this is 45, and this is 45, then I know that this is 3 square root of 2. So this measurement of this side is 3 square root of 2. So the length of the hypotenuse is side times the square root of 2. We already know the side, so it's going to be 3 square root of 2 times the square root of 2. Square root of 2 times square root of 2 gives you square root of 4, and we know that square root of 4 is 2, so 3 times 2 equals 6. So the length of the hypotenuse is 6. And this is a 45, 45, 90 right special triangle. In triangle ABC, angle A is a right triangle and angle B is 45. So this is 45, this is 45. Find BC. If your answer is not an integer, leave it in radical form. So we know in a 45, 45, 90 right triangle, this measurement is the same as this measurement, which is going to be equal to the side times the square root of 2. So if this is 10 feet, and this is 10 feet also, so it's going to follow this pattern that we have here. So it's going to be the side measurement, which is 10, times the square root of 2, and then it's feet. And it did say to leave it in radical form, so there it is. The length of a hypotenuse of a 30, 60, 90 triangle is 9. So I'm going to draw the triangle. This is 30, this is 60, this is 90, this is 9. Now it says to find the perimeter. So if the hypotenuse is 9, just like in this triangle, we have the side is S. Remember that in the 30, 60, 90, the shorter side is always half the hypotenuse, and the height of the triangle is half of the hypotenuse times the square root of 3. The shorter side of this triangle is going to be 9 over 2. And the other side will be 9 over 2 times the square root of 3. Now, if you want to find the perimeter, that means you have to add 9 plus 9 over 2 plus 9 over 2 times the square root of 3. So P equals 9 plus 4.5. So 9 plus 4.5 is 13.5 plus 4.5 square root of 3. That would be the perimeter. Number 11, find the value of the variable. If your answer is not an integer, leave it in simplest form. So remember that we're dealing with a 30, 30, 60, 90. So this is the hypotenuse. The shorter side will always be half the hypotenuse, and the altitude will always be 1/2 the hypotenuse times the square root of 3. So here, the hypotenuse is 10. This is 30. So the shorter side is 5. So the altitude of the triangle is going to be 5 times the square root of 3. Now in a 30, 60, 90, like I said earlier, the hypotenuse can be used to find the other side measurements. The shorter side is half the hypotenuse, and the altitude is 1/2 times the square root of 3. So here, we know that this is the hypotenuse measurement. So to find the shorter side, you're going to have, y is going to be 1/2 the length of the hypotenuse. So it's 16 square root of 3. So the length of the shorter side is going to be 8 square root of 3. So this will be 8 square root of 3. Remember that the longer leg will always be half of the hypotenuse. In this case, it's 8 square root of 3 times the square root of 3. So square root of 3 times square root of 3 is square root of 9, so you have 8 times the square root of 9. And the square root of 9 is 3, so 8 times 3 is 24. So the length of the longer leg is 24. The length of the shorter leg is 8 square root of 3. And the length of the hypotenuse is 16 square root of 3. So once again, we have a 30, 60, 90-degree triangle. The shorter side is 11. And we know that the hypotenuse is always double the shorter side. So in this case, it's 22. And the length of the longer leg will be the shorter leg, which is half of the hypotenuse, times the square root of 3. So the length of the hypotenuse is 22. The length of the longer leg is 11 square root of 3. Number 14, write the ratios of sine of x and cosine of x. What I taught you in class, remember that sine will always be opposite of hypotenuse, cosine will be adjacent or hypotenuse, and tangent will be opposite over adjacent. So the sine of an angle is going to be the opposite side over the hypotenuse. That's going to be the ratio. Cosine of an angle is going to be adjacent over hypotenuse. So if you're looking for the sine of x, you're going to have to focus your attention on x, and you have to give me the opposite measurement. In this case, so you're going to write sine of x equals the square root of 119 divided by the length of the hypotenuse. In this case, it's 12. Now for cosine, this is the adjacent side. So the adjacent side is going to be 5. So you have cosine of x equals 5 over the length of the hypotenuse is 12. 15, write the tangent ratios of y and z. So remember, go back to what I taught you, the mnemonic statement. Sine is opposite of hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if you're trying to find the tangent of y, you focus your attention on y, and the opposite is 7, and the adjacent is 4. Now that's for y. Now if you want to find the tangent of angle z, so you go to z, what is opposite in this case? It's 4. And what is adjacent? 7. And that's it. Use a trig ratio to find x. Okay, so you have sine opposite over hypotenuse. You have cosine, which is adjacent over hypotenuse. And then you have tangent, which is opposite over adjacent. So sine is opposite over hypotenuse. That's not going to work. Cosine either, because it's adjacent over hypotenuse. That's not going to work, so it has to be tangent. So how do you set this up? You're going to write tangent of 40 degrees equals opposite, which is 4, over adjacent, which is x. Okay, what I like to do is I like to keep the tangent 40 like that. So it's going to be x times tangent of 40 degrees equals 4. And then I'm going to divide by the tangent of 40 degrees. I'm going to divide by the tangent of 40 degrees. So x is equal to 4 divided by tangent of 40. But before you do that, you do got to go to settings, document settings, and you want to make sure that the angle's in degrees, because if it's in radians, it's going to be wrong. So I'm going to get out of here. I'm going to go to calculate. So I'm going to say 4 divided by, and to find the trig, you see where it says trig? And you're going to select tangent of 40. So you want to round to the nearest tenth, so it's going to be 4.8. 17, we have a right triangle, and you have to look at at this mnemonic statement. Mnemonic. So sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Have you noticed we don't have the hypotenuse measurement? So the only one we can use is opposite and adjacent. So you're going to write tangent of 55 is equal to the opposite in this case it's 8.9 divided by the adjacent. So now what you do is you cross multiply, so you have x times the tangent of 55 equals 8.9, and then you divide by the tangent of 55. Remember that you have to check your document settings, make sure it's in degrees. So now let's go ahead and let's calculate this. So we have 8.9 divided by trig, tangent of 55. Round it off to the nearest tenth. So it's going to be x is equal to 6.2 centimeters, okay? 18 is another right triangle. Also, go back and refer to your mnemonic statement, SOHCAH TOA. And you notice that we don't have the hypotenuse measurement. We do know we have the opposite and we have the adjacent. So once again, we're going to use tangent. So you're going to write tangent of 30 degrees equals opposite, in this case it's x, over adjacent is 10. So I picked tangent since I had the opposite of the side of the 30-degree angle, and I picked tangent because it has the adjacent. So you got to understand how to identify opposite and adjacent. This is always the hypotenuse, of course. It's opposite the 90-degree angle. So x is equal to the product of tangent of 30 times 10. So go to trig, tangent of 30, and over here what you want to do is you want to write 10. 10 times tangent of 30. In this case you get 5.77, so approximately 5.8 units. Okay. A slide 4.1 meters long makes an angle of 35 degrees with the ground to the nearest tenth of a meter. How far above is the ground to the top of the slide? So this is your opposite, and this is your hypotenuse. So, and this is your adjacent side compared to the 30 degree. So you got to check SOHCAH TOA, and you notice that we use opposite and adjacent. No, we're going to use hypotenuse and adjacent, so we're going to use cosine. So you're going to write cosine of 35 degrees, and it's the ratio of the adjacent side. I take that back. It's not going to be cosine. It's going to be sine. So what you're going to write sine of 35 degrees is equal to x over 4.1 meters. So to solve this, all you have to do is find the product of sine of 35 times 4.1. So you write 4.1 times the sine of 35. So approximately the height is going to be 2.4 meters. The students in Mr. Collins' class use a surveyor's measuring device to find the angle from their location to the top of the building. They also measure the distance. The diagram shows the angle, measure, and the distance to the nearest foot. Find the height, so we're looking for the height of the building. This is adjacent, and this is opposite, and this is your hypotenuse. So to figure out the height, you got to look at your mnemonic statement. So you have SOHCAH TOA. So what you're going to have to use is opposite adjacent, so it's going to be tangent. So you have tangent of 72 degrees is equal to x over 100 feet. So to find that distance, you have to multiply tangent of 72 times 100. So you have 100, and then you have tangent of 72. And so the height of this building is 300, and it's set to the nearest foot, so it's 308 feet. That's the height of the building.